Hello there, this is Ms. Nakayama, and today's lesson is 8.3 Matrix Operations. I'm going to try to go through this quickly because I know that y'all did all of this last year. So our objectives are to refresh your memory on using matrix notation, understand what it's meant to have equal matrices, there we go, add and subtract matrices, perform scalar multiplication, solve matrix equations, and then multiply matrices. So we have a lot to cover, but again, you've done it all before. So let's make sure you remember. Remember, a matrix is just an array of numbers. An array means that it has rows and columns. Actually, I'm going to highlight this. Rows and columns. And it has brackets, y'all. If you don't put brackets around it, it's not a matrix. So when you show your work, you need to, in your practicing problems, you need to put brackets around your rows and columns. Okay? They are denoted with capital letters, A, B, C, D, whatever, and the capital letter X to represent a variable. It could also be a lowercase letter if it enclosed in brackets with I and J representing the rows and columns. But more often than not, we're going to see it as just a capital letter. And I mentioned before that an element in the matrix, any element can be denoted by a lowercase letter, again with a subscript representing I and J, which are your row and column of the matrix. A matrix, the order of a matrix, M by N, is giving the number of rows and then the number of columns. If you ever drank RC Cola, you remember the R comes first. And of course, if M equals N, then we know we have a square matrix. So what you'll have to be able to give me, this is example 1, even though it doesn't say it. I hope the others are numbered. No, this is example 0. Okay, so what is the order of A? Remember, order represents rows and columns. So we say the order of this is it has 3 rows. Remember, rows are horizontal, columns are vertical. That's what you see in front of a house. So my number of rows is 3 and my columns are 2. So it's a 3 by 2 matrix. B says identify A sub 1, 2. That means first row, second column. First row, second column is -2. Next one, A sub 3, 1 is third row, first column. Third row, first column is +1. That's all it is. Okay, 2 matrices are equal, okay, if they have the same order, M by M, rows and columns, and if all the corresponding elements are equal. So, where did that go? Okay, that's fine. All right. So, and we add and subtract matrices by adding or subtracting elements in the corresponding positions. Okay. So you're going to see this is in the upper left-hand corner. That's in the upper left corner. That's A11 and A11. So we add those two together or subtract them. So let's go do example. This is example 1. So that last one was example 0. Okay. So you have to pay attention, y'all, to the sign in between the matrices. So in this particular case, it's plus. They have the same order. They're both 2 by 2s. So I'm going to add the elements that are in corresponding positions. So -4 plus 6 is 2. 3 plus -3 is 0. 7 plus 2 is 9. And -6 plus -4 is -10. Okay, I'm adding corresponding elements. 7 and 2, -6 and 4. All right, look at this example. Okay, this is example 2. This time we're going to subtract. So in this one, we have a 3 by 2 and a 3 by 2, but again, same corresponding. 5 minus -4 is 9. 4 minus 8 is -4. -3 minus 6 is -9. 7 minus 0 is 7. 0 minus a -5 is +5. And 1 minus 3 is -2. So that's our answer. That's all you got to do. All right, properties. Commutative, associative, additive identity. The additive identity is 0. Additive inverse is like the opposite. Okay, Definition of scalar. We have two types of multiplication with matrices. The first one is called a scalar. Okay, we've had scalar before. We had vectors. It's just a fancy word for a number, and it looks denoted with a little letter C. And if you do, then that means that you're going to go take that C and multiply each element of A by that number. So then we say that CA is a scalar multiple of A. But more importantly, this is what you're going to have to be able to do. Okay? If I need to find negative 6B, then okay, that means I'm going to take every element in B and multiply it by negative 6. So negative 1 times negative 6, negative 2 times negative 6, 8 times negative 6, and 5 times negative 6. And that's what you got. Okay, that was a simple one. They can get a little more complicated. So this one, and if you have one like this on your lesson check, y'all, it would be in your best interest to put down what this is before you combine them, if you want any partial credit for things going wrong. Okay, so to start off with, I'm going to go do 3 times A. 3 times negative 4, 3 times 1, 3 times 3, and 3 times 0. Then 2 times negative 1, 2 times negative 2, 2 times 8, and 2 times 5. And then I'm going to add those together. Negative 12 plus negative 2 is negative 14. 3 plus negative 4 is negative 1. 9 plus 16 is 25. And 0 plus 10 is 10. And again, that's all we got. So it is pretty simple and straightforward. Properties of scalar multiplication. Okay, you've got the associative property, means I can multiply the two scalars first before I distribute, or I can distribute one of the scalars and then distribute the other scalar. Okay, the distributive property, you can have a scalar distributed over two matrices, or you can have two scalars and the matrix goes to both of those. Okay, now solving matrix equations. Okay, y'all, I'm going to tell you this is example 5, but a lot of people get tripped up when they try to take this and put it here and this and put it here and solve. And it's like, that looks really funny. X is a matrix. It's a capital letter. Okay, so it represents a matrix. So I'm going to encourage you to take this problem right here and go solve it for X. So I'm going to come over here. 3x plus a equals b. If I got to solve for x, I got to get the a to the other side. So I'm going to subtract a. And then I'm going to divide by 3. But there's no division with matrices, so I'll write it as 1/3 b minus a. So then I'm going to go plug in what my matrices are. So x equals 1/3 b minus a. So what is b? b is negative 10, 1, negative 9, 17, minus 2, negative 8, 0, negative 4. And then I'm going to go combine what's in my parentheses. So negative 10 minus 2 is negative 12. 1 minus negative 8 is 9. Negative 9 minus 0 is negative 9. And 17 minus 4 is 13. And then I have to distribute the scalar. So to distribute that scalar, 1/3 of negative 12 is like negative 12 divided by 3. So that's going to be negative 4. 1/3 of 9 is 3. 1/3 of negative 9 is negative 3. And then I have 13 over 3 because I got to give exact answers because they're not going to tell me to round. Okay, so that was scalar multiplication. Now we have matrix multiplication. And matrix multiplication, y'all, is just like the order of a matrix. You multiply the rows by the columns. Okay, so I've kind of color-coded this example here for you. But this is a 2 by 2 and a 2 by 2, so I'm going to end up with a 2 by 2. And if you will keep in mind whatever element it is, so this first element is the first row, first column. Well, that means you're going to multiply the first row by the first column, which I have underlined here in green. Well, AB is the first row in green, and EG is the first column in green. So when you multiply those, A times E plus B times G. You don't have to go in order, but if you remember what this is, what element. So this element right here, I'll go down here. This element here is the first row. Nope, It's the second row, first column. So I'm going to multiply second row by the first column, which is in pink. So that's going to be CE plus DG. And then we go over here to upper right. That's going to be first row, second column, which is in blue, AF plus BH. And then the last one is second row, second column, which is going to be CF plus DH. Okay? But if you remember this key concept of its rows by columns and you figure out the element that you need, then hopefully you won't find it very difficult. So let's go do one. All right. So A, this is example 6. A is 1325, B is 4610, and I have to multiply those. So you don't have to show me all this work when you do it, y'all. There's a lot of mental math, but if you do and you miss one little thing, obviously it helps you on the partial credit front. So this very first one, first row, first column, I'm going to multiply first row times the first column. So that's 1 times 4 plus 3 times 1. Then I'm going to go first row, second column. First row, second column is 1 times 6 plus 3 times 0. Second row, first column is 2 times 4 plus 5 times 1. And then second row, second column is 2 times 6 plus 5 times 0. So to me, showing your work is either writing all this out, which you can, or you can just write these products. So you could just write 4 plus 3 and then 6 plus 0. Either one of those, and I think that I might do that on a future one, but any one of those is an acceptable way to show your work. Okay? So let's go from there, and we're going to have 4 plus 3, which is 7. 6 plus 0 is 6. 8 plus 5 is 13, and 12 plus 0 is 12. So you do love to learn to love zeros in matrices. Okay, so that was just straight up showing you how to multiply it. But what's even more important is when is it defined and when it's not. And the definition of matrix multiplication, the product is the answer to a multiplication problem. Okay, if I have an M by N matrix A and an N by P matrix N, then the product of AB is an M by P matrix. Okay, because you're multiplying the rows by the columns. Okay, so the columns of the first matrix must be equal to the rows of the second matrix. These two numbers, I know y'all did this last year, have to be the same. And if you look at this right here, this is what the order of the new matrix is, M and P, which is what I wrote right there. Okay, so let's do 2 more examples and then we're done. All right, multiplying example 7, find this product. So the first thing I got to do is find out whether or not it's defined. So this first matrix has an order of 2 by 2, and the second one has an order of 2 rows, 4 columns, so it's a 2 by 4. So I look and see that these first two are the same. So these are the same. And since they are the same, you can kind of cross them out, y'all, because the outside numbers are the order of your new matrix. Okay, so it's going to be a 2 by 4. And again, this time I'm writing them as the products instead of what you're multiplying. So first row, first column is going to be 2 plus 0. And I'll go across. First row, second column, 3 plus 15. First row, third column, -1 plus 12. And first row, fourth column is 6 plus 3. And then I'm going to go down to the second row. And 0 plus 0, love those zeros. 0 plus 10. 0 plus 8. And then 0 plus 2. And then I'm going to simplify that. And I'm going to have 2, 18, 11, 9, 0, 10, 8, and 2. And that's what we got. All right, last example, number 8. Find the possible product. And it says it every time. Okay, if possible, find the product, which means first thing you ought to do is find the order. So we just switch the order of these two. And this is 2 by 4, and this is 2 by 2. And those two numbers are not the same, therefore it's not possible. So if you're interested, here are your properties of matrix multiplication: associative, distributive, and associative property of scalar. So it doesn't matter. The order matters because, y'all, this is really important because what we're missing there is commutative. But these two matrices, these are the two matrices. We did first the smaller times the big one, and then we did the big one times the small one, and we didn't get the same answer. That means commutative property does not hold true for multiplying matrices. Okay, if you have any questions, please don't hesitate to email me or come see me. Thank you so much for watching, and y'all have a great day.